Go ahead and get started. So, quadratic functions in its basic format. If it's written in standard form, that's y equals ax squared plus bx plus c. So the only two variables are x and y. A, B, and C would represent numbers. A, B, and C represents numbers. So you look at the very first function that we have, y equals 2x squared minus 8x plus 5. So I'm putting the general formula directly underneath it. A is always in front of x squared. A is always in front of x squared. So that's 2. B is always in front of x. So B is equal to negative 8. C is always the number that has no variable attached to it. So that's positive 5. So A is always in front of x squared. B is always in front of the x. C is always the number with no variable attached to it. So definitely important to know how to identify those, both in this unit when we graph, and next unit when we'll be doing factoring and quadratic formula. So it's absolutely important to know how to identify those parts. So in the case of example 1, that's in standard form. Is it always going to be in standard form? No. So in the case of example 2, rewrite y equals 8x plus 3x squared minus 9 in standard form, and then identify the coefficients. So this is what we have, and we want it in this format. So obviously that doesn't match up. So you want the x squared term to go first. So this 3x squared has to move. So just remember, if you're going to move 3x squared, you got to move the sign along with it. X is going to move behind it, and then minus 9. So that's your rewrite. And then you solve it, or then you answer the question. Told you to identify A, B, and C. So A is 3, B is 8, C is negative 9. Any questions, examples 1 or 2? All right, then example 3. So example 3, same rules apply. That's what we're trying to rewrite, and then we need to identify A, B, and C. So A is something, B is something, C is something, and this is the format that we want the function in. All right, so what would come first? So that's got to get put in standard form. So what would come first? I can't leave it like that. You're looking at example 2. We're on example 3. X squared. Remember, x squared comes first. And then plus 5. That's the only thing that's left. So negative 7x squared plus 5. So the a value is negative 7. What's the b value? Zero. So b is 0. Remember, b is always in front of the x term. If there is no x term, then there's no b value. 0. Remember, the c value always has no variable. C value has no variable. So again, I appreciate the right answer and I appreciate the attempt. I would rather you get it wrong so that I can show you why it's wrong. We're going through it in class. This is when you want to get it wrong if you don't quite understand what's going on. So if A is missing, B is missing, or C is missing, they're zeros. So any questions, examples, 1, 2, or 3? So first thing, you gotta know how to put it in standard form. You gotta know how to identify A, B, and C. So let's evaluate. So evaluating a quadratic function, just a reminder, you are following the order of operations. Plug the number in, work it out using the order of operations. So just a reminder, that's parentheses, exponents, multiply or divide from left to right, add or subtract from left to right. So those still apply. So example 1. So evaluate the function f of x equals x squared plus 5x minus 7. So remember, f of x is the same thing as y equals. So we're going to change that to y equals. So we have y equals x squared plus 5x minus 7. So part A, evaluate y when x is equal to 3. So that means take 3, plug in for x. Take 3, plug it in for x. So now we have to do our order of operations. So parentheses means you have something in parentheses to work out. So you just have the number 3, so there's nothing to work out. Now we do our exponents. So 3 squared gives us what? Three squared gives us what? I know it's not 6. 9. 9 plus 5 times 3 minus 7. Do our multiplication. So 5 times 3 is 15. Nine plus 15, 24. So you end up with 17. So basic problem, pretty straightforward. Part B. Not as straightforward, but can still be solved. Evaluate the expression x equals negative b over 2a. So we're still using the same function, but we're solving negative b over 2a. So a and b have to come from the formula, come from the function. So let's identify those first. Based on the function, what's a? You got x squared with something in front of it. If there's no number in front of a variable, what's understood to be there? Let's see. So what's the number in front of x squared? I can let you try it now. You have to take the final 3 weeks. That's like 2 weeks. Something like 3 weeks. So you got x squared. So what's the number in front of x squared? If you're stuck and you don't know, say that you're stuck and you don't know. I'll help you. Let's see. All right, so it seems like people are stuck, so let's look at it. Yeah, if you're stuck, you have to ask for help. So, you have x squared, the number in front of x squared. If there is no number in front of it, it's 1. To get b, you look at the number in front of x. And for c, c is the number that has no variable on it, -7. Granted, you don't need c to solve that problem. We don't need c to solve that problem. But we do have enough now to answer the question. There's your a, there's your b. That's the problem. So negative b is negative 5 over 2 times 1. So negative and a positive 5, it's negative 5. 2 times 1 is 2. And negative 5 over 2, you can leave it like that, or you can give it as the decimal, which is negative 2.5. But I would make sure that you know how to give it both ways, especially if it ends up being a multiple choice situation with the final, which part of the final is multiple choice, part of it is worked out. Questions, part B. All right, problem 2. And if you have questions, make sure to ask. If you don't have questions, that's fine. If you do have questions and you don't ask, then I can't help you there. Closed mouths don't get fed. So, new function, same rules apply. Evaluate the expression using the coefficients. So first you got to identify A, B, and C, and then you solve it out. So since part A is just like the problem that we just finished, let me give you a minute to start the problem. So go ahead and take a minute, switch that back. Now we'll go to simplifying. So simplifying is very, very similar to what we did in unit number 1. So when we simplify a quadratic expression, you're still using the 2 basic principles from unit number 1. That being distributing and combining like terms. You're still using the same 2 principles. You just have to be a little bit careful with how everything works itself out. So when it's a quadratic expression, there's 4 things that show itself up more times than not. First off, first thing you have to remember, if you multiply a variable times itself, you're going to end up with an x squared term. So if you have 4x times 5 plus 2x, that's nothing more than distributive property. So 4x times 5 gives you 20x, and 4x times 2x, which is 8x squared. Remember, anytime you take a variable times itself, you end up with x squared. So that's what you get when you simplify it. So the reason why I'm turning it around is to put it in standard form. Let's put it in standard form. Any questions? Example 1. Talking about this part? Talking about the part next to the 8? Yes. So when you multiply a variable times itself, that gives you x squared. So anytime you take x times x, that automatically converts to x squared. Problem. Any other questions? Example 1. All right. Example 2. So when you're multiplying 2 binomials, that's when you use FOIL. Now, your Algebra 1 teacher might have taught it using Punnett squares. So if Punnett squares works better for you, use it. So I'll show it both ways, and you feel free to keep the way that's going to work better for you. So x minus 2 times x plus 5. So FOIL means first, outer, inner, last. Let's x times x. X times x, which gives you x squared. X times positive 5, which is plus 5x. Negative 2 times x, negative 2x. And negative 2 times positive 5, which is negative 10. So again, that's first, outer, inner, last. Now you combine like terms. So your only like terms here, 5x minus 2x 3x. And then that's simplified. Any questions on the FOIL part before we do it using Punnett squares? Since I know some of you might be more familiar with Punnett squares. All right, so for those of you who are more familiar with the Punnett square method, so we have x minus 2, x plus 5. So x times x gives you x squared, x times negative 2, negative 2x, 5 times x, 5x, 5 times negative 2, negative 10. So if there's anything that you would need to combine, you would most likely see it on the diagonal. So there's your 5 and your 2. So that's still x squared plus 3x minus 10. So again, which way you do it, I personally don't have a preference. As long as you show your work so I can see what you did, then I personally don't care which way you do it. Questions, example 2. All right, example 3. So example 3, we added a different wrinkle to it. What happens if there's a coefficient outside the parentheses? So if you've got a coefficient outside the parentheses, multiply it into the first set of parentheses, and then you continue using the Schroeder property, FOIL, Punnett squares, etc. So notice you have a 2 times x plus 4 times x plus 11. So this 2 that's sitting in front is only going to go to the first parentheses. You only give it to the first parentheses. So we only give this 2 to the first parentheses. So if we multiply it out, 2 times x is 2x, 2 times 4 is 8. Two x plus 8 times x plus 11. Now this problem looks exactly how problem 2 looks. So you can either do FOIL, or you can set it up as the Punnett square. So again, either way should get you to the same answer as long as you do your computation correctly. So in the case of FOIL, 2x times x is 2x squared. 2x times 11, 22x. 8 times x, 8x. 8 times 11, 88. Then you're just combining like terms. Then you're combining like terms. Again, if you did it using Punnett squares, you would get the same answer. Question example 3. do example 4. I think it's graphing, so I can say graphing for 36. Nice clean break. All right. So if you have a parentheses squared expression, so in other words, you have something in parentheses raised to the second power. So rewrite the parentheses twice, and then you do the distributive property, FOIL, etc. I've seen a lot of people get this problem wrong time and time again, and it's because of one simple mistake. It's a very, very easy mistake to fix. So some people will see x plus 6 squared, and think to do x squared plus 6 squared, x squared plus 36. It is a very, very common mistake, but this is wrong. This is wrong 100% of the time. That's wrong 100% of the time. If you have something in parentheses raised to the second power, then you need to write it twice. So that minus 5 that's out there, right now we're going to leave it alone. There's nothing we need to do with it yet. There's absolutely nothing that we need to do with it, at least for right now. Take the parentheses, write it twice, and then you solve it out. You have 2 sets of parentheses, so you can either use FOIL or distributive property. Either one works. So again, I'll solve it out using FOIL. X times x squared. X times 6. 6x. 6 times x. 6x. 6 times 6. 36. The minus 5 stays sitting out there. So now you combine like terms. 2 6's put together, and 36 can go with the minus 5. X squared plus 12x plus 31. So again, the part that I showed at the beginning, that's a common mistake. It's a very, very common mistake. But it's a very, very fixable mistake. Any questions with example 4? Then when you do work it out, don't forget that the minus 5 is sitting out there. There's a lot of people that will also just solve out that part, but forget about the minus 5. So take that extra couple seconds, look at all the parts of the problem, make sure you got everything taken care of. But that's simplifying. And for most of you, it should be review. If there are particular parts that need to be cleaned up from earlier, but hopefully this helps. Any questions with the start of Unit 4? The second part is graphing. This gives us a clean break to be able to do that starting on Thursday.